how's things? So in the previous video, we got a cube up, spinning around and filled in. This is what it looks like. And now in this video, I want to start to make a first-person camera, but I'm going to split this into independent tasks. The thing I'm going to do today is I'm going to get mouse movement working. We're going to look at how to read key input from Pygame, or key state in Pygame, and change things. And then I'm also going to have a look at the concept of a lookat matrix, setting up a camera. But, you know, one step at a time. I'm going to go ahead and make a function to handle keys. And I'm not going to worry too much at this point in time about how I'm representing my data. I'm just going to say, let's say that we take a camera position, which will be just a list of floats. And the thing with Python lists is that Python lists are sort of like pointers. They're references to objects. So we don't have to return a new list. All we can do, or all we need to do, is modify the elements of the list. So what I'm going to do is, first of all, now I'm going to get the status of all the keys. So I can do that with the Pygame key module and the get pressed. I'm also going to define a walking speed. And now I'm going to go in and I'm going to have a look at those keys. So actually, what I'll do, this is a good exercise. What I'm going to do is I'm just going to pop in at a breakpoint, and this will set it so that I can debug. And what I'll do is I'll go ahead and handle my keys here. And for the camera position, actually it doesn't matter. I'll just put that in for now. It's a placeholder. We're going to not do it. But the purpose is I want to look at what's in these keys. So I'll go ahead, debug the Python file. We get to this point. We are done. Okay, and up on the left I have my local variables, just my camera position at this point. Now I can just step over, and I've also got keys. It's not super helpful. So that was nice, that was interesting. Now instead of doing that, let's just print keys. This will probably not go well, but find out. Let's give it a go. False. Okay, cool. So as you can see, it looks like we have a really big sort of collection thing. It's actually called a scan code wrapper. So think of a scan code wrapper as being pretty similar to a dictionary. With a dictionary, you can pass in a key of a certain sort. So instead of saying, you know, get element 0 of this thing, we can say get element A, get element 3, you know, special codes. And for that special code, it will give me back some output. So I'll do something very similar here. So I'm just going to treat this thing as if it was a dictionary, and I'll say, okay, so this is how we would test, for instance, whether the A key was down. Now, if the A key is down, I want to move to the left, which would be, if I've got my screen coordinates, so X is running left to right, where negative X is on the left, positive X is on the right, and then Y is running up and down, and Z is like forwards and back. Then to move left, I will be decreasing my X coordinate. The opposite of that is moving right, so key D. And then we have A and S. Sorry, W and S. And these will be affecting my Z coordinate, which is my depth, like forwards and backwards. Okay, now where was I? So in the case of W, we want to be moving forwards. By the right-hand rule, if we curl our fingers, you know, from the X to the Y, our thumb's pointing right back at us. So positive Z is actually backwards. That's this case here. going backwards. Going forwards, we should be decreasing our Z value. So I'm pretty happy with that. I'll just sort of get this other stuff out of the way. So the next thing I'm going to do is I'm going to make a function which will start setting up my view matrix. Now, think of a view matrix as following. By default, we have the world, and we have like a camera object somewhere in the world, and we have other objects somewhere in the world, and the origin of that world is fixed. It's 0, 0, 0. It's just an arbitrary point. It really doesn't matter. But when we want to do useful stuff, when we want to see things from the camera's perspective, we need a coordinate system where the camera counts as the origin. And if we're just not worrying about rotation, but we're just worrying about position, a way we can achieve that is to subtract the camera's position from every object in the world. And then another way to think about that is if we've got this view model matrix, which is applied to every object in the world, then we can incrementally modify that matrix. And think of it as we take the view model matrix, and before we apply it to any objects, we incorporate a translation which is doing the opposite of the camera's positions. Okay, so enough talk. So let's go apply camera view, and just the same as before, we're going to need to take in the camera's position. Now the first thing I'm going to do is actually unpack that camera position. Camera position is a list of floats. I'm understanding that it's going to have 3 elements in it, and so this is just unpacking the elements of that list into 3 individual variables. So first of all, I'll go ahead and we'll clone the matrix stack, grab a new matrix to work with, and then I'll go translate float, and I will be, again, subtracting the camera's position, doing the opposite of the camera's translation, if that makes sense. Thinking about the matrix stack and the way this works, every time we push a matrix, that gives us a new matrix, but it also, the new matrix that we get is a clone of all the transformations which have come beforehand. So if I had multiple objects, what I would do is I would set up the camera view first, and then I would repeatedly, for every object, push a matrix that clones the camera's operation, and then put in that object's specific operation, transformation, and sort of go like that. And so what I'm getting down to is, I guess I'm saying, let's use these functions. Here's how we use them. So we've got all this stuff. We're defining all this like model parameters and stuff. I'm also going to go ahead, maybe a little lower down here. I'm also going to define the camera position, and I'm going to set it a little bit back from the cube. So just set it 5 units back from the cube. Okay, so it's go time. So in our loop, we'll go ahead and update the camera's position based on the state of the keys. And then before we go ahead and set up the transformation for that cube, we're also going to incorporate the camera's position. So again, I know that I'm talking in circles like a lot, but what this is doing is this is sort of setting up the camera's viewpoint, the camera's, I want to say perspective, but that's perspective, projection, different thing. This is setting up the camera's view, and then we go ahead and make the object, and then after that we reset the transformation. So think of this as all one bundle. As a matter of fact, we can probably bundle all of this stuff together. So these 4 lines are specifically drawing the cube. And then I'm going to put in another reset transform. And what that's doing is that's resetting the camera's view transform. So I know I know it might look a bit strange when we just have one cube, but that's the order of operations. So let's give this a go. So we can see now that the cube is a little bit far away from us. We can go W for forwards. Yep, that works. S for back. A for left, D for right. Cool. And any combination of those. So we've got our keys set up. We're setting the camera's, view point. And yeah, we are one step closer to having a first-person camera. So I hope you enjoyed this, had some fun as always, and I will see you again soon. Bye.